Welcome to Amiible's second video and what was going to be our first live stream until I got this message from YouTube. So we're going to try to record and upload within half an hour to get this up in time. Anyway, today we're going to be looking at bioreactors because livestock burp methane and their dung and urine emits nitrous oxide, both of which are crazy bad greenhouse gases. On top of that, the land lost to livestock is completely unsustainable. So we want to develop open source methods for anyone to ferment tasty, nutritious protein from sunlight and air. Our first video explained the reasoning. This video is all about the bioreactors. I'm Martin Curry, and today I'm joined by the wonderful Gerrit Martin. Hi Gerrit, how are you doing?
Hi Martin, good. How are you?
Yep, other than the slight rattles from YouTube, I'm fine. So where are you joining us from today?
Well, I'm joining you from Swansea here in Wales, which I guess is just on the other side of the island from you.
Yep, indeed. So yeah, for those who don't know, I'm just south of Glasgow. And yeah, what's the weather like in Swansea today?
Well, we had a unexpected, nice and sunny day here, which I think is very uncharacteristic for the season. But yeah, it was a nice day in Swansea.
Excellent, cool. Right, so if anyone has any questions or comments, please do add them in the comments. We'd both love to hear your thoughts. Obviously, we can't answer live, but we will attempt to answer through YouTube as soon as we can. As I said, so today we're going to be focusing on experimental bioreactors. So Gerrit and I both independently picked the same bioreactor. I will keep the brand secret for now because we're going to be unboxing, finally, mine almost live today. So I'm very excited about this. As you can guess from the box, ours didn't cost anywhere near as much as any of these would. I generally hate unboxings. So we're going to try and keep it down to 3 minutes. Then we'll hear about Gerrit's first experimental data and explore the fatal flaw in it. But first, Gerrit, what inspired you to buy a bioreactor in the first place?
So I think it was about 8 years ago where I did a DIY bio course where as a hobbyist I was learning more about microbiology and I got interested in bioreactors because I saw that you could grow things in them. At the time, it was more things like more in the medical domain, things like insulin and rennet that's used in cheese. But at the time, there wasn't really anything that was available on the hobbyist scale. It was all quite commercial, big, expensive things that weren't really accessible for a hobbyist like myself. And then it was about a year ago that I got quite inspired by George Monbiot's book Regenesis, which was talking about precision fermentation and how you can also use bioreactors for growing food essentially, growing growing casein that's in cheese, or even doing biomass fermentation with all these, where you can basically grow all different kinds of proteins. And I had another look, and I went through all the kind of all the new projects that have been started since the last time that I've looked at it. And I eliminated quite a few because they didn't seem to be active anymore. But there was one open source project that looked quite exciting that we both independently came across and both independently decided, wow, this looks like a great idea to try out, and I think we'll get to that in a minute.
Yeah, brilliant. Yeah, so we too considered lots of open source bioreactors. Pretty much everyone that I found was ruled out just because I couldn't see any evidence, like Gerrit, that it was still in active development. So you can see the full list at amiibo.org. I'm going to encourage you to add any open source bioreactors that you find to this list. Now, the moment I've been waiting for months, it's the unboxing. But first, I should say that this, let me just get us up here. So this video is not sponsored, and evidence here is on the box. Hopefully, can you read that, Gerrit? So yeah,
Yeah, I can just go and make that out.
yeah, cool. I paid 430 Canadian dollars and 16 cents. And that gave me three things: the bioreactor, pumps, and some cables. And then, unfortunately, I Gerrit was quite clever. He got two at once. I just got one, thinking I would buy another one. But the problem then, I was hit by the customs duty on it, which goes on the postage as well, and then is the extra handling fee for it. So I wish I'd got more. But anyway, we have what we have here. Yeah, Gerrit, there's a risk. This is going to get very boring. So yeah, if you could just try and keep people's interest while I go through this. And could you give me a 3-minute countdown as well?
Sure, let's go for it.
So we don't go forever on this. Right. We did discuss, speaking of boring things, we discussed doing risk assessment and so on for this, but yeah, you suggested that would not make a good first video, really, a risk assessment one. So yeah, I don't know. To me, the biggest risk is sort of ongoing life of our grandchildren, etc. Okay. Can you remember opening yours? Am I doing it the right way?
Yeah, it looks like it.
Now there's something I'm doing. Oh, it's that way. Is it? I'm really confused. There we go. I've sort of got in. Oh, I've got a note there. Cool. Ah. Happy to help set up the bioreactor cloud system. That's something we're going to talk about probably on a different day. Brilliant note from Cam there. Excellent. And yes, 5mm cables and that. Right, we've got some packing stuff.
Well, you're 1 minute in.
1 minute in, oh dear, better hurry up. Right, this is the hat PCB. So this you also need bioreactor, so it's Pi as in Raspberry Pi. The computer of it is a Raspberry Pi. This is a hat that sits on top of the Raspberry Pi. If I had been thinking enough, I would have my Raspberry Pi, but we'll maybe do an assembly video later. Then we've got these are the cables. I'll maybe explain those later if we get time, but I've not got long. That's the heat plate, isn't it?
Yep.
Yep, cool. Sorry, it's not in focus. Anyway, then what we got here? Ah, wow. So this is the 3D printed assembly, I think. Now this is interesting. Can you, will it put that in focus for me? No, it's, yes.
Oh, there it goes in focus.
Does your cap look like that? I think this is a new design 3D printed cap. Am I right in thinking that your caps are like drilled through?
It looks very, very similar to the one that I have here.
Okay.
Yeah, I think
So
it may be the same cap.
Your cap's printed as well then?
Mine is not printed. I think.
Right. Yeah. So this black bit is printed on mine.
Oh right.
This
Okay.
Yeah. Right. And we've got this.
You'll have to go quick now. You're almost at your 3-minute mark.
Oh dear. Right. We've got this, which is the 2 pumps. Did you get pumps as well? Yeah.
Yep. Yeah.
Yeah. Okay, so that's so we can go in chemostat mode, which is basically we'll have stuff pumping through there, going in to one side and coming out the other side. So we've got 2 pumps, very well protected, a bunch of tubes to connect it up. We've got some, there's a word for those that I can't remember, but the things that you use to attach the hat to the thing. This looks like a fan for it.
Yep.
And that. Now I'm
Looks
blanking.
like
Do you know
the
what that
bottom
is?
plate.
Bottom plate, cool. More packing. A bioreactor badge, that's cool. And these are the caps that stop the light going in there.
Yep.
Brilliant. And I don't actually know if that's part of it or not, but there's that in the box as well. I think that's everything. Okay. The other thing that I got, or am I out of time? I'm probably out of time, aren't I?
Yep.
Right, we'll do this anyway. I got this separately from the guys that you recommended, or that your course recommended, you said, Bits Box, which is, actually doesn't say the price, that's annoying. I think it was £7 or something for a bunch of super bright LEDs so that we can do spirulina and other green stuff. Cool, right. So that's enough of that. One of the reasons I should say that we both went for these was the open source nature. So it's the software is all totally open source. I think always has been, and they say always will be. Then there's also the what else? The most of these bits, I understand, are now available, so you can print yourself. Not entirely sure about this bit, but certainly there's other bits that I'm going to be printing. And I understand that the rest of it's going to go open source by the end of the year. So even bits like that, if you're really, really brave, you could build yourself.
Yeah, you can already download the designs for the vial caps, and I think for the basically the dosing platform. So you can plug in the bioreactor and then the peristaltic motors and so on all together on a little platform that slots in together, and all those things have been open sourced already. But I think we're still waiting for the hardware itself. So basically the bioreactor hat and so on to get open sourced.
Yeah. But I would encourage you, if you can at all afford it, to support Cam and the bioreactor team, because them continuing to develop it is exactly why we've gone with these ones. But yeah, enough of that. I think, Gerrit, you've already started your work with your bioreactors. Could you take us through your initial results?
Sure. Yeah. So I started the first experiment that you do with a bioreactor that they actually have on the bioreactor website, and I think we'll put a link up to the experimental protocol for that. And it's called a control test, where you're basically, if you have two bioreactors, you can set both of them up exactly the same. So use exactly the same amount of media and inoculant, and you run the exact same experiments on the two bioreactors to try and ensure that they function exactly the same. Because if you're going to run the exact same experiment, you're hoping that your experimental results will be exactly the same. So I went ahead and did that. It's a relatively simple experiment. You go and you just have to sterilize everything before you start. I did mine in a pressure cooker. And then you make up some solution. YPD broth is what you can grow yeast in, and I just use regular baker's yeast, the same yeast that I use for baking bread. And then made some stock solution, so that is some of this broth with a lot of the yeast in it. And then you take a little dropper, take some of the yeast, drop it into the vials that also then contain some of the solution. And run the experiment. So I think let's have a look at some of the results that we got from that. All right, so the top graph there is what's called the implied growth rate. So basically what the graph shows is how quickly the yeast inside the vial is growing. And you'll see that as I started the experiment, and the temperature increased and reached a stable temperature that the yeast likes to grow at. The grow rate started increasing until a certain maximum where it basically consumed most of the available food and nutrients inside the vial, and it started dying down. And you can see then that it ends back at a growth rate of 0 there towards the end. Now, what you're hoping to see here is two lines exactly on top of each other. If these bioreactors are performing the exact same way, you would see that greenish line and the blue line right on top of each other. So there's a little bit of a difference there. I think it's still close enough that we can call the experiment a success. But there are a couple of things that could have caused this that I think we'll talk about in a minute. Let's just have a look at the other graphs that the bioreactor generates. So you've got the normalized optical density there at the top, which is basically what it's doing is recording the density by having an infrared sensor on the one side of the vial and having infrared lights on the other side. So it measures the kind of the amount of stuff inside between the sensor and the light, and that allows it to measure the optical density. Now, because these sensors between reactors can be quite different, they won't measure things in exactly the same way. So that is why on the graph, the bottom graph there, that just says optical density, you can see that there's quite a big difference between the two bioreactors. But once you normalize these values, you see that the values get a lot closer to each other. And then that optical density values can then be used to generate the implied growth rate that you can see at the top. There's one more graph that we can show you, and that is the temperature of the vials, where you can see that as the experiment started, it immediately ramped up to 30 degrees, and it stayed there at a very constant 30 degrees for most of the experiment, which I think ran for just over a day, around 30 hours. So that was
Brilliant.
the experiment.
So yeah, the fatal flaw, not really a fatal flaw, but there was quite a difference in the optical density. What do you think caused that?
Yeah, so I think the main thing is that when you do experiments with at this scale where you have really small vials, you need to be really, really accurate. And I was using, a lot of the measurement tools that I use are just the tools that I have in the kitchen. And I was using a dropper tool instead of a more accurate pipette. So, I think there are a number of things that one could maybe do to improve the accuracy of your measurements. And, not using a dropper would be one of them.
Yeah, while the tiny little 20 mil bioreactor keeps the cost of most things down, it does mean that I think we need to be extremely accurate with our measurements, and that had me kind of worried, because I'm used to paying hundreds of pounds per pipetter, and then you need a set of pipetters to cover all the different volumes that you might want. But then I found one just yesterday, I think, under £10. So I'll get one of those. I don't imagine it's going to be anywhere near as accurate, but it's hopefully repeatable and sufficiently accurate. So we'll see. Are there any bits of kit that you think are going to break the bank for us? So yeah, please do let us know in the comments. We need to research all these things. Things like autoclaves versus pressure cookers and stuff like that. Be brilliant to know your thoughts. So the intention is that I'll be here and we'll actually manage to live stream at 8 p.m. UTC, I think, next week. So yeah, please subscribe, ring the bell, and you can join us live, I hope. Or let me know if 8 p.m. UTC on Wednesdays doesn't work for you. And do also tell us what we've missed in our search for the perfect open source bioreactor. And please let us know your thoughts in the comments. Let us know what bioreactor you're using, whether open source or otherwise, and if you see any limitations with the bioreactor. So thank you very much, Gerrit. Thank you so much for joining us and sharing your results. Thanks also, for putting them online so that everyone can see them and do their own analysis and so on. And thanks everyone for taking the time to watch. Together we can help the world grow their own nutritious, delicious, sustainable and affordable protein. See you next week. Thanks. Bye.